When performing a split injection, there are several considerations that can improve the quality of your chromatography. But where should we focus our attention to get the best results? In this Restek tip, we're going to show you how to optimize your split injections, and we're going to start with liners. The higher flow rates of split injection can bring many benefits, but when paired with the wrong liner, those higher flows have the potential to cause numerous problems. For split analyses, you need a liner that allows the analytes to thoroughly vaporize and transfer to the column within the short period of time they're in the inlet. A liner containing an obstruction, such as wool, increases the surface area, which assists in vaporization. The wool also aids with sample homogenization and helps capture non-volatile material, increasing the lifetime of your column. An open bottom liner design, such as a straight liner with wool or a precision liner with wool, is recommended as these allow for unobstructed flow to the split vent. Key to split injection is the split ratio, which essentially determines the amount of sample that goes out of the split vent compared to the amount that goes onto the column. For highly concentrated samples, a higher split ratio may be necessary to avoid overloading the column. If your sample is not as concentrated, a lower split ratio will help you reach your required detection limits. Next, we'll optimize the inlet temperature. You want the temperature to be high enough to achieve sufficient vaporization of the heaviest compounds, but low enough to not cause excessive activity for reactive analytes. 250 degrees Celsius is a good starting point, but you may need to adjust this temperature to achieve the overall best peak responses for your analysis. What about the initial oven temperature? Given the fast transfer of compounds to the column with split injections, solvent focusing is usually unnecessary. Because of this, you can often start with a higher oven temperature. But if your analytes are very volatile, a lower starting oven temperature will be needed for effective retention and focusing. Initial oven temperature hold times are generally not needed in split injections due to the faster transfer of analytes to the column. However, they can be used to improve the separation of very volatile analytes.